Good day, students. Welcome to Mathgotserved.com. And this clip we're going to be going over how to identify and find the constant of variation of direct variations. This standard is covered in Algebra 1 and 2. And don't forget there are 11 practice problems at the end of this tutorial to help you demonstrate mastery. For access to the entire Algebra 1 playlist or the course materials and other valuable worksheets, just take a look at the link in the description below or visit our website at mathgotserved.com. To get us started, let's take a look at the various representations of a direct variation. We're going to start with the verbal representation. So how would you describe a direct variation verbally? Well, a direct variation, let's say x and y. So x and y vary directly. X and y vary directly if every y value is a constant multiple of x. Alright, if you multiply with the same constant multiple to every x value to generate a y value, then you will have a direct variation. Alright, so there's a special observation you can have when your constant of variation is positive. Alright, so let's go ahead and write that down. For the constant of variation, k, for k greater than 0, when x increases, y increases. Alright, so if you have a positive constant of variation, for direct variation, when one variable increases, the other increases. Okay, so when x increases, y increases, and vice versa. It's a special case of a direct variation in verbal format. Okay, let's take a look at the algebraic representation of a direct variation. The algebraic representation of a direct variation can be written as y equals mx. By is equal to ax, or y over x is equal to m. Okay, so these are the different ways that you can write a direct variation in algebraic form. And then just remember, if you want to find the constant of variation, which is k, that is simply determined by dividing y over x. Okay, so m, that slope, is your constant of variation. Alrighty, so depending on the representation you have. Now, one thing you want to note is that all these can be written in the form y equals kx. So if you can write any equation in the format y equals kx or y equals mx, then it's a direct variation. So look at y equals mx. Another way you can write it to reveal the constant of variation is y equals kx. Alright, so that's that for the algebraic format. Now let's take a look at the numeric representation. So how are direct variations represented numerically? We're going to look at two forms. We have the ordered pairs. So for an ordered pair, a direct variation looks like this. You have x1. To get the y value, you multiply by the constant of variation, kx1. And then y1, x2 for the next one. So for x2, we're going to multiply by the constant of variation, x2, to get the y. And then x3, to get the y coordinate, you multiply by the same constant of variation to get x3, to get y3. And then the pattern continues. So if you look at what's going on here, you notice that every single time what's happening, every single time we're multiplying by the same constant of variation, which is k. Alright, so that's basically how direct variations look as an ordered pair. Now, how about as a table? Tabular representation is very similar to what we have here. Let's go ahead and set that up. So if you want to write a direct variation in tabular format, let's say this is your x and this is your y. x1 to get y1, you multiply by that k value, kx1. And then for x2, if you want to get y2, you multiply by kx2. And then x3, to get the y coordinate, you multiply by kx3. So you notice the same pattern here. Every single time we keep multiplying by k, the constant of variation, to generate our y values. Alrighty, that's what a numerical representation of a direct variation looks like. How about graphical representation? So graphical, all you need are two things, okay? For graphical representation, you need a slanted line that goes through the origin. If you have those two properties, these two properties here, you are good to go. Alright, and the origin is the point 0, 0. So if you have a line that's slanted and goes through 0, 0, that is a graphical representation of a direct variation. If you have a vertical or horizontal line, those do not qualify, or a line with an intercept other than 0. So let's take a look at an example here. So if you take a look at the line I just drew, that line y equals mx or kx. So let me just write this line right here, y equals kx, or you can call it mx, it's the same thing. This is a direct variation. Why is it a direct variation? Number one, it's slanted, and guess what? It goes through the origin, 0, 0. Okay? So let's show what the origin is. This point right here, that's the origin. Right? So any linear function that looks like this goes through the origin, and a slanted is a representation of a direct variation. Okay, now we're going to put our knowledge of these forms of direct variation to use to answer the following questions. Alright, so for number 1 to 4, the instructions are as follows. For the given direct variations, what we're going to do is to find the constant of variation and write the equation. Alright, and write the algebraic equation. Alrighty, question number 1. Let's say we have the direct variation presented in a numerical format. So we have negative 12, 3, negative 4, 1, 0, 0, and 8, negative 2. Alright, so let's say we have something like this. Now, let's go ahead and find the constant of variation. Now, to find the constant of variation, what we're going to do is we're going to look at the we can do this by inspection. Let's do this by inspection first. Okay? So what do you multiply 12 by to get to 3? In order to get from 12 to 3, you notice that the signs change, right? So we're going to be multiplying by negative, and the number is smaller, so it looks like we're going to be multiplying by a fraction. Alright? So to go from negative 12 to 3, what you do is you divide by negative 4. Okay? Dividing by a number is the same thing as multiplying by the reciprocal, which is negative 1 over 4. Remember, keep change flip or drop change flip. Alright, so every single time what we're doing is we're multiplying by negative 1/4. Okay, so if you multiply negative 12 by negative 1/4, you get 3. If you multiply negative 4 by negative 1/4, you get 1. If you multiply 0 by negative 1/4, you get 0. And then if you multiply 8 by negative 1/4, which is equivalent to dividing by negative 4, you get negative 2. Okay, so just by inspection alone, we can see that um, the constant of variation, um, k, is what? By inspection, we can see that k is negative 1 over 4. All right, so now let's use a formula. Let's use a formula to figure this out to know for sure that this is in fact correct. So the formula for finding the constant of variation is k equals y over x. So you just pick any ordered pair and divide y by x, and that will give you the answer. Okay, so k, let's pick the first point, is going to be y 3 over x, negative 12. If you divide that out, how do we reduce that? We can reduce this by dividing the top and bottom by the GCF, which is 3. So divide by 3, divide by 3, and that will give us our desired constant of variation. 3 divided by 3 is 1. Negative 12 divided by 3 is negative 4. And you can just write this as negative 1/4. Alright, so our constant of variation, which is represented by the letter K, is negative 1/4. Alrighty, so you can see that you can find a constant of variation by inspection, but the formulaic approach will give you the exact answer for a certainty. Alright, so we also need to write down the equation. So the equation is given by the formula. Equation for the formula is of the form y equals kx. Alright, so y equals kx. So all we are just going to do is we're going to take our k value that we just found and plug it into this formula right here. So our final answer, the equation, is going to be, for this particular direct variation, y equals k, which is negative 1 over 4, times x. And that is the answer to the second part. Alrighty, moving along. Let's take a look at question number 2. So for question 2, let's say we have the following. Let's say we have another ordered pair. For number 2, we have the ordered pair given by a set of ordered pairs, negative 5, comma, negative 15. And then we have negative 1, comma, negative 3. And then 2, comma, 6. And then 4, comma, 12. Now, just by inspection, can you figure out what the constant of variation is? So let's try this out by inspection first, okay? So just by inspection, we want to ask ourselves, can we see the constant that x is multiplied by to generate y every single time? So from negative 5 to negative 15, from negative 1 to negative 3, from 2 to 6, from 4 to 12. What do you notice happening? From negative 5 to negative 15, that's resulting by multiplying by 3. From negative 1 to 3 times 3. From 2 to 6 times 3. From 4 to 12 times 3. So we're multiplying by 3 every single time. So by inspection, our constant of variation k is 3. Okay? Now let's use the formula for confirmation here. So the formula for direct variation k is given by y over x, okay? So let's do it. We can pick any point. Let's pick the second point. So k is going to be y over x. So if we use the second point, that would be negative 3, which is y over negative 1. Okay, so using the point negative 1, negative 3, remember you can pick any one. This is x and y. So if we use this point right here, that's what we get. If we divide that out, we will get minus over minus, you slash and dash, 3 over 1 is 3. Okay? In the first example what did we use? We were using the first point, negative 12, 3. And then here we choose the second point. It doesn't really matter. Alrighty, so this k value agrees with what we got by inspection. So let's write down our answer. The constant of a variation, which is represented by the letter k, is 3. So to generate your y values, you multiply by the x's by 3 every single time. Okay, equation. What is the equation? The equation is given by the formula y equals kx. Okay, so that's what we are going to be using for this answer. So to get our final equation, all we're going to do is take the k value that we got and plug it into this equation. Alrighty, so this 3, we're just going to take it and plug it right here. Alrighty, and then our final answer will be y equals kx, k is 3, y equals 3x. And this, ladies and gentlemen, is the answer to question number 2. Alrighty, now let's take a look at the next one. Let's take a look at question number 3. Now, question number 3, we're going to switch representations. Okay, we're going to take a look at a tabular representation here. So let's say we have the given table that represents a direct variation, and number 3, x and y. So our x is negative 16, and the y is negative 12. For negative 8, the y is negative 6. For 0, the y is 0. And then for 4, the y is 3. Okay, so let's take a look at this. We want to find a constant of variation. So we just by inspection, what do you multiply the x's by to get the y? Okay, if you take a look at it just by inspection, it's pretty difficult to figure out. I know a lot of you that are really good at this can do this easily, but for most people it's pretty hard to figure out what the constant of variation is, because it's not that obvious. Okay, what you're doing is you're not just dividing, you're also multiplying. You're multiplying and dividing, right? You're multiplying by a fraction where the numerator is not 1. So does that mean it's impossible to do? What hope do we have if the inspection approach is too difficult? Well, we can always use a formula, right? The formula is always a sure way to go. So the formula for the constant of variation is y over x, right? So you can pick any one you want. Let's pick the first one, okay? So let's use that to figure out our constant of variation. So using negative 16, negative 12, in the formula, k is y over x, y is going to be, so this is y and this is x, is going to be negative 12 over negative 16. So slash and dash. Let's see, what is the GCF of 12 and 16? The biggest number that goes into 12 and 16 is 4, so you divide both bottom and top by 4, and that yields 3 over 4. So that's your constant of variation. So you see why it was hard to figure out, right? Because it's not that easy. So constant of variation, k, is 3 over 4. Alrighty, now we can use that to figure out what our equation is. But let's write down the formula for the equation. The equation for a constant of variation is y equals kx. So we're now just going to take our k value that we found and plug it in here to give us our equation. So our equation is what? Our equation is y equals 3 over 4x. Alrighty, so there you have it. Alright, let's go ahead and take a look at problem number 4. Problem 4 is another tabular representation. So let's say we have this table right here. for number 4, let's see what we have. So for, let's say we have x and y as follows. So x is -4 and y is 8. And then when x is 2, y is, I'm sorry, when x is -2, y is 4. When x is 0, y is 0. When x is 1, y is -2. Okay, so what is the constant of variation here? Can we figure this one out by inspection? That's the question. And the answer is yes, totally. We can figure this one out by inspection. So, if you look at -4, what do you multiply -4 by to get +8? We know it's going to be a negative number because the signs keep changing. So the sign changes here, the signs change here, and then here is 0, so it doesn't really count, and the signs change here. So we're going to be multiplying by a negative number. So what negative number do you multiply 4 by to get 8? 2, -2, right? What is -2 times -2? 4. So it's -2 here again, and then 0 times -2, and then 1 times -2. So, ladies and gentlemen, just by inspection, we can see that we're multiplying by -2 every single time. This one is not as hard as number 3. So, we can see that by inspection, our constant of variation is -2. Alright, so let's verify using the formula. The formula for constant of variation, k, is y over x. So pick any ordered pair you want. Let's pick the fourth one. Alright, doesn't really matter which one that you use. So using 1, -2, we have k as equal to, so this is your x and y over x. So let's see, y is -2 over x. -2 over 1 is just -2, and that agrees with our previous answer. So the constant of variation is given by k, which is -2. There you have it. Okay, now next thing we're going to do for number 4 is we're going to find the equation. What is the equation here? That's the question. What's the equation? So we're going to write down the formula for determining the equation. The formula is y equals kx. So all we're going to do now is take the k value and we're going to plug it into this formula right here. Bam, and then that will give us the answer. Alrighty, so the equation for the constant of variation is y equals -2x. And there goes your final answer. Alright, so we're done with numerical representations. Let's switch gears and take a look at an algebraic representation. Okay, so for question 7 through 8, these are the instructions. We're not just finding constant of variation, we're identifying. Alright, so for 5 through 8, we're to determine if the equation is a constant of variation, is a direct variation, sorry. If it's a direct variation, if so, find what? Find the constant of variation. Okay? Find the constant of variation. Alrighty, so for question 5, let's say we have the equation y is equal to -5 over 2x. Now, is this a direct variation? The answer is absolutely. It's yes. How do we know it's a direct variation? Because it is of the form what? Is of the form y equals kx. So if you can write an equation as y equals a constant times x, it's a direct variation. Okay? So what is the k now? The k value is the coefficient of x. Okay, so we have y equals kx as a general form. So what is k? The coefficient of x is k when it's written in y equals kx form. So the constant of variation k is negative 5 over 2. Okay? Alright, number 6. Let's say we have the equation y is equal to 3x plus 1. Is this a direct variation? The answer is no. Why is it not a direct variation? Because of this 1 that's added on here, okay? It's not a direct variation because y equals 3x plus 1 is not of the form or let's put it this way, cannot be written in the form. There's nothing you can do to make it that form, okay? So let's rephrase that. Cannot be written in the form. There's nothing you can do. Cannot be written in the form written in the y equals kx form. Alright, whatever algebraic procedure you carry out on this, you can make it y equals kx because 1 is being added on to it. Okay, how about the equation 3y equals negative 12? Is this a direct variation? Well, you might say, oh, it's not y equals kx, but hold on for a minute. Remember, we talked about this earlier. If it's written in the form by is equal to ax, it is a direct variation. Why is that? Well, check this out. Oh, sorry, there's an x here. Alright, so let's look at this. If you have this equation, can I write it as y equals kx? The answer is yes. If I divide both sides by 3, like this, I will have y equals negative 4x. Bam. So it is a direct variation. Okay, so the answer is yes, because it can be written in the y equals kx form. That's the reason why. And then as you can see, the constant that x is being multiplied by in the y equals kx format represents your constant of variation. Okay, so there it is right there. That's your constant of variation. So our constant of variation k is negative 4. Alrighty? Okay, moving along. Let's take a look at question 8. For question 8, what if we have the equation given by, so question 8, what if we have 3x plus 3y equals 15? Alright, so let's go ahead and determine if this is a constant, a direct variation or not. So the goal here is, can we write this in y equals kx form? So what we're going to do is just get y isolated and see if we have kx on the right side. Okay. To achieve that, we are going to start by solving this equation for y. So we subtract 3x from both sides of the equation. Okay. When we carry out that subtraction, what's the result? It yields 3y is equal to negative 3x plus 15. And then we'll proceed to divide every single term by 3. So divide by 3, 3, 3. And your final answer is y equals negative x plus 5. Now, is this in the y equals kx form? The answer is no. So this is not a direct variation because y equals negative x plus 5 cannot be written in the y equals kx form. Okay? That's why it's not a direct variation. Alrighty, let's take a look at question number 9 to 11. Now these ones are in graphical representation, and we are going to determine if they are direct variations or not. If they are direct variations, then we will state why and find the constant of variation. Alrighty, let's take a look at number 9 first. So number 9, if you take a look at number 9, is this a direct variation? This is a direct variation. Why? Yes, because remember the two things we talked about before? First of all, it's slanted. And what else? Secondly, it goes through the origin. 0, 0 goes through the origin, which is 0, 0. Alright, so if you have a slanted line going through the origin, there's the origin right there. 0, 0. Then you know that it's a direct variation. Okay, so this is a direct variation. Now what's the constant of variation? All you just have to do is use the formula y equals kx. You just need to, k equals y over x. You just need to find any point on the line and then just use that point. Okay, so in this particular case, this is what's this? This is 2 and this is negative 3. So we're going to use the point 2 comma negative 3 to solve for the constant of variation. So k is y over x, your y is negative 3, your x is 2, so you have negative 3 over 2. There is your constant of variation. Okay, so let's go ahead and write that down. Constant of variation is, let's see, constant of variation k is negative 3 over 2. Nice. Let's move along to number 10. So let's take a look at 10 for a second. Take a look at that graph for a second. Is this the graph of a direct variation? The answer is no. Why not? Well, because it doesn't go through the origin. It misses the origin. Does not go through the origin. It satisfies the first condition, which is slanted, but the second condition is going through the origin is not satisfied. Okay, it does not go through the origin, so it's not a direct variation, hence we do not need to find the constant of variation. Number 11, what do you think about number 11? Yes, it is a direct variation. Why? Number 1, it's slanted, as you can see, and 2, it goes through the origin. Goes through the origin 0, 0. Alright, so this is a direct variation. Now, what is the constant of variation? We're going to use the formula again. K is equal to y over x to find it out. So just pick any point that falls on the line, preferably a lattice point. So let's pick this point right here. So this is negative 1, 2, 3, 4. Negative 4. And this is what? This point right here is negative 1. So this point that we're picking is negative 4, negative 1. Alrighty. Okay, so in order to find the constant of variation, we're going to be using the point negative 4, negative 1 to do the calculations. Alrighty, so k is going to be y over x. Y is negative 1 divided by x, which is negative 4. If you divide that out, you end up with 1 over 4. Okay, so your final answer, the constant of variation, which is k, is 1/4. So there goes the answer to number 11. Okay, so now is your turn to demonstrate mastery of the standards we just covered. Here we're going to give you 11 problems to try out, and then let's see how well you do. Alrighty, so here are the 11 practice problems we'd like you to try out. So what we'd like you to do at this time, go ahead and pause this video presentation, try out all these 11 problems, and then when you're done, you click back on the play button, and then we're going to reveal what the correct answers are, and you can see how well you did. Okay, so go ahead and pause the video at this time and work on these 11 practice problems. Alrighty, hopefully you had a chance to try out these examples. Now let's take a look at what the answers are. Alrighty, so the first problem, question number 1. The constant of variation, the k value here is negative 1/3, and your equation y is equal to negative 1/3 x. For number 2, your constant of variation is 4, and your equation y is equal to 4x. For number 3, your constant of variation k is given by 2/3, and your equation y is equal to 2/3 x. For number 4, your constant of variation is 1, and your equation is y equals x. For number 5, this is a yes, and your constant of variation k is 7/4. For number 6, this is a no. For number 7, this is a yes, and your constant of variation k, when you solve for y, is going to be -3. Okay. For number 9, this is a yes, and your constant of variation k is 1/3. Alright, because you have the point here. And then for number 10, this is a no, because you notice it goes through the origin, right? It does not go through the origin, so this is not a direct variation. Okay, so number 10 is a no. And then for number 11, that's a yes, and goes through this point right here. And then if you use that to find your k value is going to be -3, just -3, -3/1, which is just -3. Okay, so how well did you do at these problems? We'd like to know. Tell us how you did in the comment section below. If there are any questions or clarifications that you have, just include that, and we'll be more than glad to respond. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of direct variation, to give us a thumbs up or a like. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel for updates to other presentations such as this. As indicated earlier, if you have any questions or comments, just place it in the comment section below, and we'll be more than glad to respond. And to gain access to the remainder of this review series on other valuable resources, take a look at the link in the description below, or just visit our website at Mathgotserved.com. Thanks again for watching, and have a wonderful day. Goodbye.